Tweet requesting on a 30.
Manly American 628.
Can you give me some situation update, please?
Roger on that one.
Did you know that those types of communication are just a few that are made possible through spectrum? Come along, let's explore this dynamic electromagnetic world. All wireless communication uses spectrum. It's, simply put, a range of electromagnetic radiation found naturally in the air on different wavelengths or frequencies that people have found a way to tap into and use. This covers a wide range of signals that we know, such as visible light, X-rays, radio and television, cellular communication, two-way radio communication, wireless data networks, and on and on.
It's in the air, as it were. It's a natural resource that is available for use, but is highly valuable in particular frequencies, and those particular frequencies tend to be the radio frequencies. So the spectrum is much wider than the radio itself, but radio frequencies are the ones that we use to actually communicate wirelessly.
Understanding the physics of it all does get quite technical, and it actually took scientists many years to discover that there are signals within the air that are invisible and usable, other than visible light.
So what we have done in modern times is find a way to encode that signal, use the natural properties of physics, and send various signals, receive various signals, decode them, and use them to see pictures on our television, use them to hear voice on our cell phone, use them to listen to the radio, and so on and so forth.
So how it actually works is that if I wanted to send a message saying hello, a source would have to be created that would cause a vibration, or what they call an oscillation, in order to interpret the signal. Well, I'll let the expert explain.
If you were to type HELLO into some device, that device would take each letter, create different oscillations that would mean H separate from E, from L and O, transmit that over a radio frequency network. There would be a reception device or an antenna at some point that you want to send it to. Once that is received, that device, which understands the system that you use to encode it in the first place, would be able to say, oh, this oscillation means H, this one means E. And once it breaks it down, it can spell back that word and print it on a screen.
So the next time you send a text, receive an email, or talk over the phone, just remember it's all because of spectrum. Over the years, the telecommunications industry in Jamaica has grown, and so the demand for spectrum has increased. This gave birth to the regulatory body, the Spectrum Management Authority, the SMA, in 2001.
Our job includes monitoring of the spectrum, it includes licensing of new users, it includes managing and responding to any interference issues.
Up to December 2010, the government had issued licenses to over 400 spectrum users and authorized 17 island-wide broadcasters and 10 community broadcasters. This covered all local radio and television stations, in addition to marine, aeronautical, security communication systems, and all other spectrum users at the time. With so many users, monitoring of the spectrum becomes critical to ensure adherence and prevent interference. Here again is where the Spectrum Management Authority comes in. It's the authority's job to know the amount of space available for each category of users. And with this comes band planning.
The band planning function looks at the overall range of radio frequencies that are available for use. It starts with adopting international guidelines that are every few years established by the International Telecommunications Union. We customize those guidelines for Jamaica.
Armed with a national frequency allocation chart and allocation table, the Spectrum Management Authority is able to assign specific frequency bands of the spectrum to various services, such as broadcasting, satellite, cellular, and government. That's one of my favorite FM stations. With more applications for frequencies than available channels, there was a suspension of the assignment of FM frequencies in 2007 as the SMA was unable to satisfy the market demand. In the meantime, the Spectrum Management Authority is crafting plans to make new spectrum available for wireless mobile broadband services. The planned digital switchover project will also allow the SMA to improve or increase the allocation of frequencies for broadcasters.
If we are able to move into a digital system, we would be able to compress a lot more in the same space.
So for now, we continue to use and enjoy the spectrum that's out there, even if we barely understand it, to make life just a little bit more interesting.